All right, lesson 7. Students will be able to add, subtract, multiply, and simplify expressions. So lesson 7 is actually going to be covering 8.8. 8.7 is not covered by this class or this course, and we're not doing all of 8.8. So this is what we're doing. Add, subtract, multiply, and simplify using complex numbers. Complex numbers is new. Imaginary numbers is new. Write skill 1, write imaginary numbers in terms of I. All right, right here. Since the square of any real number is positive, there is no real number that is the square root of a negative number. For example, if you put in your calculator, what is the square root of -1? It's going to come up as error, okay? What is the square root of -4? It's going to come up as error. They're not real numbers, okay? They are imaginary numbers. So this is another type of number that has come up through need here. Imaginary numbers are commonly represented by the lowercase I. Like E, pi, right? These are symbols that stand for a certain number. What's pi? Pi is 3.14, blah, 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 blah. It's a long decimal, right? It's not a variable. It doesn't change. Pi is that number. It's a symbolic representation for the number 3.14 something, 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 something that we round to 3.14. E is also a number, 2.71 something, 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 something. So it's not a variable. It stands for that decimal, okay? So I stands for imaginary numbers. It's not a variable. It represents a particular amount, okay? The particular amount is the square root of -1, and I is the square root of a -1, okay? It's an imaginary number. In fact, I squared is the square root of -1 times the square root of -1, which is -1. So if you have I squared, you have a -1, okay? So that's kind of the formula for that. And we need that so we are able to perform operations like add and subtract, math operations, with imaginary numbers, okay? And with negative radicands, right? This is a radican. So for example, if you have the square root of a -25, you can't put that in your calculator because it's going to say error. But what you do is you recognize that is the square root of a -1 times, using the product rule, times the square root of 25. The square root of 25 is 5. The square root of -1 is I. So we write that as 5i. Okay, we put the letter on the right side like we would an X. Okay, that's typically how you see it, and you typically see when you pull the I out, you put it on this side, on the left side of the radical sign, because I don't know if you can, so if you put it here, it's kind of hard to see that it's not under the radical still, so you'll see that I typically, when a number comes out, remember we always put it to the left of the radical sign. So the square root of a -6, take out square root of 1 times the square root of 6. This is going to turn into an I, so you get I square root of 6. Okay? This is going to be square root of 1 square root of 7. This is going to be I times this is going to be that right there. Okay. 24. Square root of, what is the largest perfect square in a 24? That would be a 4, right? Times 6 times a -1. Right? Do you recognize all this? So 4 times 6 is 24 plus this. So this is going to be 2i square root of 6. Okay? So this is what we're doing. So let's practice that for a second. So this is going to be the square root of -1 and the square root of 64, because 64 is a perfect square. So that's an 8. This is an I, so my final answer is going to be 8I. Okay. Notice I keep flip-flopping around the order when I'm working on things. That's unimportant as long as you put it together correctly at the end. Okay, so this is just going to have an I come out. So this is square root of -1, square root of 5. So this is I square root of 5. Okay. I square root of 2 times -3. So -3I. That I does not come out negative. Okay. Comes out this -1, square root of -1 is I. It's not a negative I. So it's a positive I times -3 is -3I. Okay. So let's see. Just as routine, I usually take the negative out first, but that, again, this order doesn't matter. 16 and a 2. So clearly going to have that left over. That's an I. That's a 4. So 4I square root of 2 is the order you want to put your final answer in. Let's see. Square root of 1, -1, square 9, square root of 2. So that's a 3. That's an I. Square root of 2. And there's a 6 out here. So 18I. Right? 6 times 3 times I, square root of 2. That goes there. Okay? All right, so that's an imaginary number, is an I. Right? What about complex numbers? Complex numbers is everything. Is all the numbers possible. So with this definition of imaginary numbers, the square root of a negative number is no longer undefined. We will be able to perform basic math operations using imaginary numbers to define a broader set of numbers called complex numbers. So under complex, let's say all numbers are complex numbers. Okay, and then within the complex numbers, there's imaginary numbers and there are real numbers. Okay, under real numbers, there's irrational numbers and rational numbers and so on. But complex numbers is the all-encompassing group for everything, all numbers. So this is the form of a complex number. Okay, I is an imaginary number. So that means the A and the B are real numbers and the I is the imaginary number. The A is called the real part and the B is called the imaginary part. So real part, imaginary part. Okay? Combine terms when adding by adding the real to the real and the imaginary to the imaginary. When subtracting, don't forget to distribute a -1 through the parentheses. So, let's stick with the green color here. Okay, so here's the problem right here. All right? We are adding this complex number to this, we're subtracting this complex number from that complex number. Okay? So real to real, complex to complex, and if you're subtracting, don't forget to distribute the -1. So step 1, distribute this negative through, just like you would any other thing. So right here is the new problem. All right, then I'm ready to combine the real parts together to get my 1, and then combine the imaginary parts together to get -8I. So there is that added together and simplified. Okay, so let's try that. All right, this is an addition. I noticed that right off, so there's no negative to distribute. So real plus real, 6 minus 2 is 4. And then 5 minus 6 is -1. So my final answer is 4 minus I, because this is the I part, right? You can put the 1 in front if you want to, but like the variables, x is the same as 1x. Well, I is the same as 1I, so you don't have to put that 1 there, okay? This is a subtraction, so I make it a plus, distribute this, change all the signs by distributing my 1, and then add like with like. So -1 plus a -2, or -1 minus 2, however you want to slice it, it's going to be a -3, right? And then this is going to be plus 13i. That's all there is to these. That's all we're doing. So 5 minus 5 is 0. Oh, wait. Wait. Let's not get carried away, because what are we doing with this here? So hang on, let me think about that again. So my eye went to the fact I didn't have a negative here, but look at this here. I need to process. Order of operations says I need to process this first. So I'm going to stay in the parentheses, and a negative, this is a -1 and a 4. So this is an I and a 2, and that's coming out being multiplied. So this is 5 minus 2 times 2 times I is what all that is. So that's going to be 5 minus 4I plus, and then over here, what is this? This is I, right? So this is -5 plus 7i, right? This is 7 times the square root of -1. So this is I. So that's this. All right, then you're adding, then you're adding the real parts, which is still 0. And then you're adding a -4 and a +7. You're going to get a 3i. So your final answer is just 3i. Okay? We'll put the rest on another video.